My name is Alexander Agrios. I'm an associate professor in environmental engineering. My background is environmental engineering with kind of a large dose of chemistry. So I tend to teach some of the classes that have a chemical focus, like environmental engineering chemistry, the environmental lab class. It seems that so many of the messes that we environmental engineers go around trying to clean up come ultimately from the ways we get energy, and particularly from burning stuff. So we have coal ash and all kinds of air emissions, leaking fuels that contaminate groundwater, and all the impacts we get from extracting these things from coal mining, from drilling for oil, from fracking for natural gas. We can get away from a lot of that if we can find ways to get energy from the sun without any of those impacts. Most of my work now is about finding low-cost technologies for solar energy generation. So in a solar cell, you have a material that absorbs light. It makes a pair of negative and positive charges, and the hard part is separating those charges and collecting them on opposite sides of the solar cell. There are special layers you need to do that only let one kind of charge pass through, and that's one of the big challenges, is how to make those layers. We're still doing work together with a group from Rutgers University, a group that does synthetic chemistry, so they make molecules and I incorporate them into devices for solar energy production. I also have collaborations with a couple different people in UConn in engineering, actually one chemical engineer, one electrical engineer. They both do somewhat related work on techniques that are useful in making some of the layers needed to make some of these low-cost solar cells. So we're trying to kind of put what we know together and use their techniques to make these very thin but very well-made layers that we can use to make a complete device that makes the charges, separates them the way they're supposed to, and gives you a negative terminal and positive terminal that you can use to power what you need to power with it.
The reason I joined this lab to begin with is because I'm really interested in renewable energy. More and more people are thinking that renewable energy and with some sort of focus on climate change in their future careers is becoming more and more of a focus of students of my generation. I think that the work I'm doing here is really important and valuable for my future career and hopefully for others in the world.
The more we can push the technology and bring costs down, the more it proliferates, the wider it gets adopted, the faster it gets adopted. To me, that's the biggest thing we can solve to push toward a clean future.